Hey there, class. We're here today to look at an example from our vectors notes. And this actually was a vector note that we did before. This was example number 1. In fact, this is really example number 3 that we're going to do. However, in the past, what we did was we did this through graphing methods only. So if you want to refresh your memory with that, you can watch the video on that. I'll link to it for you. Today, what we're going to look at, though, is looking at how to solve this using mathematical methods. So we're not really too worried about the drawing as much as it is to scale. I am worried that you understand what it looks like and what it, you can get a general idea, but we're not really too worried about having this thing to scale. So what we're going to do here is we are going to come up with a strategy and then implement that strategy to try to add these two vectors together. Okay, so the strategy I've come up with, and we can use this strategy only because we do have a right triangle. Keep in mind that the Pythagorean theorem will allow us to find a third side of a triangle, which in this case, the third side of the triangle is this resultant vector, which is what we're trying to find. We can use that because, again, we have a right triangle, and that'll find us the magnitude. Now, it's often forgotten in these, but you have to remember that a vector has both magnitude and direction. So we do need to find to fully develop this vector, we do need its direction as well. So to find a direction, what I'm going to do is I'm going to use some kind of trig function to do that. So what we'll do here is I will go ahead and we're going to take our strategy and we will implement it to see how we can actually end up solving this. All right, so in the first step, finding the magnitude, we do have 3 kilometers and 4 kilometers, so those are our A and B respectively. When we square this, we're going to get a 9, and when we square this, we'll get a 16, and that's going to equal our R squared. 9 plus 16 gives us 25, and to get the R by itself, we're going to have to do a square root on both sides. And so in this case, the R will equal 5. So again, the units that we had there were in kilometers, so our magnitude is going to be 5 kilometers. We are going to also use a trig function here, and let's go back up to our triangle. I think my goal here will be to find this angle right in here. We'll call that theta. And as we do this side over here, the B, will be our opposite side, and the A will be our adjacent side, and this will be our hypotenuse. So when I go about doing this, I like to use the numbers that I've done the least calculations with, which would be the given numbers. That would be this one here and this one here. So that's the opposite side and the adjacent side. So I'm thinking the tangent function is probably the best option. Now, ultimately, you could use any of the trig functions here, cosine or sine. But again, due to the fact that this was not a calculated number and that one wasn't, I'm going to use those two. So let me set this up. Our trig function that I'm going to use is tangent. So it's going to be tangent of theta equals the opposite. The opposite was our B, and B was 4. And the adjacent was A, which was 3. To solve this, to get tangent by itself, what you're going to have to do is you're going to have to do the inverse tangent function. So I'm going to have to do the inverse tangent function to this side as well as this side. All right. Now, one red flag you want to watch out for here. Make sure you are in degrees mode. If your calculator is not in degrees mode, you will not get the correct answer. So you definitely want to double check that before you actually do this. And again, so what you'll be putting in is you're going to be putting in the inverse tangent of 4 divided by 3. So let me go ahead and do that, see what I get. Okay, so after putting that in my calculator, I did find that the angle here was 53.1. And this makes sense to me because this is our bigger side, so I would expect this angle here to be the bigger angle. So 53.1 seems to make sense to me. This is also consistent with what we found before, notice here, this was the 39 degrees. That would have been this angle right in here. So again, this was done by drawing before, so 53 and 37 are complement of one another. So the fact that we did this through graphing methods, I feel pretty confident that this answer we got here is definitely on in the ballpark of what I would expect. So let's write our answer as a final answer. I did find the resultant vector, had a magnitude of 5 kilometers, and it was at an angle of 53.1 degrees. And again, that's this angle here between the north and the vector. And so that's going to be east of north. And so this is what I expect to get when I add these two vectors together in a mathematical way.